everybody. My name is Roy Osherove. I am based in Israel, and today we're actually going to talk about putting the XP in Scrum. I'm actually going to start by sharing the screen. Okay, so this talk is about putting the XP in Scrum. And really, I want it to be more of a conversation, not just a talk. So if people have questions in the middle, you can technically just raise your hand, and if I'm pausing, I'm happy to take questions in the middle. Just a little bit about me. I'm a software consultant and developer over 20 years in the business, and I've gotten to work in a lot of different companies, small and large. I've gotten to fail quite a bit, so I've made quite a few mistakes, still make them today every once in a while. And this talk is about a lot of stuff that I've learned the hard way, so that you don't have to. Or maybe you've also learned it the hard way. We're just all sharing the pain. And of course, this talk, the idea for this talk was born in, as you can probably guess, a lot of frustration. And I'm guessing a lot of people here feel kind of frustrated at some of the current situations that they see either in their own company or in other places. Maybe your company is perfect, but in many companies, there is this eternal struggle of, trying to be, or at least saying that we're agile and we want to do all these things and we want to achieve all these great things. But then in reality, when you actually get down to the computer and you're actually trying to code and you see exactly what the code looks like, and you see exactly what does it mean when people are paying attention to quality or not paying attention, at some point, it doesn't matter how many posters you have on the wall that say quality matters. At some point, it's just literally just about the code that ends up on your computer. And I think that's the source of truth. That's what we're going to talk about today, is what's the difference between what we say that we want and how do we actually achieve it. And unfortunately, I don't have a lot of magic beans to sell today, which means there aren't any magic solutions that I'm going to give. But I will give some anecdotes on where to look for the root causes, and maybe some suggestions on what we can do for next steps, things that have worked for me in the past. Okay. Now, the second thing that I want to mention is that there has to be a reason why we want to be this kind of, why we are using Scrum, why we're doing all this Agile stuff, etc. And to me, the true implementation of agility in the software world ends up as continuous delivery or true continuous delivery. I think that continuous delivery is really the true indicator of whether the company is able to do that stuff. And that's at least close to where we want to be in many companies. So the Netflixes, the Googles, the Facebooks, and I realize that not all companies can achieve that, because if we're working in the, let's say, healthcare industry, if you're working on MRI machines, that looks a bit different. But at the very least, we can talk about some of the other practices, such as continuous integration, not just continuous delivery, because even those things are still broken in many organizations. And again, it doesn't matter how many posters they have on the wall. So we have this idea that the organization wants to be agile, right? This kind of we want to be agile. And many organizations started by adopting agile processes. So I call them increment-enabling processes. So whether it's Scrum or SAFe or other forms of whatever it is you want to work in, there are processes that organization chooses to work with, and those processes are promising something. They're promising that you're able to work incrementally and deliver incrementally and work in small batches and plan those batches and have some kind of predictability. But they're all under that umbrella of agility. And of course, as we all know, just adopting a process doesn't actually make us agile, because in many organizations that adopt these agile processes, eventually what ends up happening is that they just rename a bunch of stuff and everything stays the same. So we just put the word sprint at the end of every couple of weeks, and now we're agile. Or we put a demo, and then now we're agile, and all that stuff. It's really painful to see, because there is a lot of hope in these initiatives, and people are not out there trying to scam the organization. They really are trying to make a difference. And I think that they're just missing a bunch of ingredients to make that happen, because the process is important. It is a part of it. The process is the part in the system of change that enables and gives permission to do things in a different way. However, in many organizations, everyone has, well, allegedly has the permission to do things in a different way, and yet nobody does it in a different way. Everyone still does it the old way. So sometimes it means that we're just giving lip service to the permission, and we're just saying that we're using this process, but we're not really changing the rules in the organization to fit. And so there's many of these kind of bottlenecks that exist in the organization that are not being solved just because we rename things. The second thing that enables organizations to be agile, from my point of view, is the idea of that automated pipeline, the automated feedback loop, that kind of like a factory floor, is that when you give it something, it will take it all the way to production or to a specific environment as close to production as possible. And that pipeline is also very, very important. And I'll talk about that because I do believe in a pipeline-driven organization. But unfortunately, as you probably know, many organizations have a lot of pipelines. Many organizations have jobs and Jenkins jobs for here until eternity, hundreds and thousands, and everything is still stuck. And the releases are still taking a long time, and quality still sucks. You have now a bunch of people responsible for the pipelines. The name is now DevOps, etc. But just because there's a bunch of automation, the company does not actually enable that. It enables a part of it, but the organization still doesn't behave in the new way. So now we have organizations that are using agile processes, and they've also automated a bunch of their pipelines, but still things have not changed. Maybe some of you have already felt that. And to me, that's kind of that, what is that magic that enables some organizations to actually work differently, that differentiates? And to me, that magic is exactly the point of this talk, which is the engineering practices that exist inside the process, that the process usually doesn't talk about. And those engineering practices can be collected from multiple different methodologies. But XP seems to be the most prevalent, that actually encompassing a lot of the practices that truly enable continuous delivery. And so this talk is going to be about that edge. But first, I just want to explain that organizations that adopt a specific process and the organizations that adopt a bunch of pipelines that do automation still doesn't mean that the pipeline here ends up delivering something, because people might not actually be merging into the master branch, maybe because they're afraid, maybe because they've been working on a feature branch for 6 months, maybe because there's 17 people between you and a pull request approval. Eventually, if the pipeline is sitting there empty with nothing to deliver, or it delivers something from 6 months ago, then it doesn't matter how much automation we have. And same thing for sprints. Just because we're working in sprints and we have a product owner and all that stuff, that's good. That's about communication, and it's about building that trust and understanding what we're building. It doesn't mean we're actually able to deliver within a span of 2 weeks or 1 week or even 1 day. It just means that every iteration we become more and more frustrated because we're not able to deliver. So in terms of the increment enabling process, I just want to talk a little bit about Scrum, because Scrum has been a huge success in terms of marketing. Right. So XP and Scrum kind of started out life in the world where people knew about them relatively around the same years. And then Scrum won. It won hands down. Like some people don't know what extreme programming is, because it kind of was left in the dark for a while because it was extreme. Like it had the word extreme in it. But Scrum is not extreme. Scrum is a rugby term. It has amazing marketing abilities. It has a huge business that enables coaches to be certified and enables people to work together to teach other people. It has this amazing community of people. And a lot of them care a lot about this stuff. But at some point, it has almost dwindled down into bare words, is that people Even though Scrum might have started out in a specific way, people still just do lip service to it today. So you end up with coaches that will go to a 2-day Scrum Master course, and then they talk about things that they've never experienced, and they ask teams to do things that they can't, where the teams are not even ready to do them. So coaching in itself is its own thing. But Scrum, as a process, is not a bad process, because it does give us sort of a structure that we want to work with, and that structure is very simple. And that's part of the power of Scrum, is that the structure is very simple. You got these 2 to 4 weeks. You got the 24 hours of daily Scrum meeting. You have sprint backlog. You have product backlog, and then magically, you have a potentially shippable product increment. And the reason I say magically, because no one explains to you how in those 2 to 4 weeks it magically ends up here. What happens in the middle of those 2 to 4 weeks? Other than that daily Scrum meeting, how do we work? What do we work on? What do we consider good? Those things are not answered in Scrum, because Scrum is a process, it's not an engineering methodology. So in that regard, that's actually good news. Because that process is relatively empty, the good news is that you can push things in the middle of it that drive it. And one of those things can be XP. The bad news is that Scrum is empty, which means that any company that adopts it and doesn't put something in the middle is basically screwed, because they believe, maybe through marketing or maybe just being wrong, is that just by adopting it, everything will change. And the answer is no, because all it does is it bubbles up some of the problems. It bubbles up the problems, it doesn't solve them. And that's kind of where we are today. So there's all these practices and all these meetings and practices are about communication between people, and that's great. But they're not about the engineering that happens. It's not about the oil in the machine. And the oil in the machine, that's the thing that actually makes the machine run. That's the thing that enables small delivery. What does it mean to have small delivery? It means that the user story is small, but can I work on a small user story? I consult for a lot of organizations, and one of the common things that happens is that the product backlog or the sprint backlog, there's tasks and user stories, and even if the user story size is small enough, the team cannot deliver it, because from an engineering practices point of view, it's there's too much going on. There's too much risk. There's too much technical debt. There's too much manual testing going on. There's a lot of stuff that's going on. So the team itself is not able to deliver fast, even if the chunk is supposed to be small. And even if they do deliver it fast, it's not to the master branch, and then it goes through this entire cycle until it gets to the master branch, and by then it's already 2 sprints after. Now, Scrum itself usually works for smaller teams, and then if you want to scale it, then you have less and safe. There's a bunch of these high-level meta processes, and these again are another form of giving us a process. But just by adopting it doesn't mean that we're actually enabled to become we're not actually able to deliver faster, because again, those processes, they're about communication between people. They're about putting time blocks in specific locations, and that's great in many ways, but it's still missing that piece, that magic that we're talking about. On the other side of it, there is the pure technical work of pipeline-driven automation and culture, or the world of ops and DevOps, or today. And I'll just give a brief thought about where we want to end up in that world. And even if we end up with that, we're still missing something. And I'm a big believer in a pipeline-driven organization. What is a pipeline-driven organization? It is an organization that has a cooperative pipeline. Instead of having multiple small pipelines with people in the middle, people from the entire organization, I'm talking about specific products, will contribute to the same pipeline. So security will contribute security tests to the main pipeline. Testers, dev, compliance, ops, they will all contribute tests to the same single pipeline that runs technically per commit. And the idea is that when the pipeline is green, we actually deliver. There is no one at the end that says, well, these stages are green, so let's move to the next stage. The pipeline actually makes the tactical decision of when to upgrade the version, when to deliver software to specific environments, when to roll back. Feature toggles play an important role here. But this type of pipeline requires not only culture change, but it also requires engineering practices. So a lot of companies find it really difficult to adopt a pipeline-driven mentality, even though their company is made up of hundreds of pipelines. Because the difference between this and what most companies have is that between each of these expertise, there are actually people in the middle that will stop and say, okay, you're good to go. And then only then the next pipeline for the next, let's say, compliance or ops is allowed to run. So it's basically a waterfall pipeline in many companies where the developers will have their own pipeline, testers will have their own pipeline, or that the test high level stuff, security will have its own pipeline, stuff like that. And there are people in the middle of each pipeline after it runs that allow it to move to the next level. So people are bottlenecks. In a pipeline-driven organization, there are no people in the middle. And as soon as something is green and it passes, it automatically triggers the next pipeline. And that means that it becomes one singular pipeline where every test in there has a veto. It can actually break the pipeline because pipelines break when a test fails. So we don't want to deliver if something fails from any of these people. But if everything passes, we want to deliver. And of course, the next question is, are you actually able to have a pipeline that you trust so much that when it's green, you always deliver? And the answer for some organizations is no. I don't trust my pipeline enough so that when it's green, it's already done. It's already delivered. What does it take to actually trust the pipeline to get it at that level? It means that we have to take care of it. We have to teach it how to make decisions. And those decisions are done by tests. So we actually have to contribute tests to the pipeline and teach the pipeline to make those tactical decisions. And if we don't like the test, if we don't trust the test enough, we don't trust the pipeline. So even if it's green, we're still not confident enough. So in a pipeline-driven organization, probably 50% of our job is to teach the pipeline new tests. So every time we add a feature, the pipeline gets to decide if the feature is actually working, right? And if it didn't break everything else. So instead of a human making a decision, the pipeline is making that tactical decision. Now, is that actually possible? And the answer is, of course it's possible. Companies like Netflix and Google and Facebook are actually implementing it. That's what I mean when I say true continuous delivery, is that those companies actually have pipelines that make their own decisions, and there are very little, if any, humans in the process at all. So once code gets into the pipeline, it gets delivered if everything passed. That's how much they trust the pipeline. Can you get there? The answer is yes. How do you get there? This is this whole discussion about pipeline and culture and ops and how do you teach people. But even if you had all that automation and pipeline, we still need someone to write all those tests, right? Tests are part of that culture. They're part of that engineering practice. Feature toggles and branching and all that stuff also belongs to that pipeline, but it also is an example of engineering practices. So companies that try to implement continuous delivery, but don't implement critical engineering practices like feature toggles, trunk-based development, test-driven development, very small increments, they will not be able to deliver into such a pipeline because this pipeline requires actually a lot of work. And that work, someone actually has to do it. And if you're too busy working on something else, you're never going to do that type of work. Let's see. Okay, so now we're moving into the XP part, because that, to me, this is the missing ingredient from what a lot of organizations do. And as you'll see, it's very obvious that it's missing. It's very obvious why it's missing. And if I asked anybody, why aren't you doing it? You'll all have a really good answer why you're not doing it in your organization. And that's, of course, the problem that we want to solve. But to me, XP or engineering practices, in particular, those from the XP world, are really the glue that enables a team to work in such an environment, right? We're not talking about convincing people right now. We're talking about people that want to do a good job and want to work in that world, need to use engineering practices from the world of extreme programming. So just a little bit about extreme programming. If you don't know Kent Beck, pretty smart guy. He wrote a bunch of books, did a lot of stuff, and he wrote, and I think he's mainly the person attributed to extreme programming. He wrote a book called Extreme Programming Explained. That's how I learned about it. I think more than 20 years ago. And the main aspects of XP, if you talk about just in the main values, are simplicity, feedback, respect, courage, and communication. Now, some of them will already map to stuff that you know, right? Communication, the feedback stuff. Simplicity is about the design and the implementation of the code. Respect sometimes is missing between enabling respecting developers' opinions about what it will actually take them, respecting the developers' time to actually work the same amount of hours per week, respecting the opinion of the customer instead of making up an opinion for the customer. There's a lot of respect that's missing all around. The other thing that's missing a lot is courage. It's really, really scary to implement some of those practices because systematically, some of them can actually be risky to your job. And that's one of the main reasons why a lot of organizations don't do them. There are systematic things that actually prevent us from implementing them. Now, those are the values. Some of the practices, so even XP, and this is the book, by the way, even XP has its own kind of a process, right? There's a project heartbeat, there's daily communication. So it's not unlike some of the parts of Scrum in a way, but it also adds that heart in the middle. Let me just, it adds like these 4 different main loops, which is testing, planning, design, and coding, all working together. And it's actually being very explicit, right? It literally talks about those things. Let me just make it show you. This is from xprogramming.com. I'll just show you that it has all these processes. I'm going to jump into all of it, but I'm not going to talk about all of it. I'm going to talk about the technical stuff. But you can see that XP by default has a lot of things that you might already know from other methodologies. It has spikes. This is a technical spike for building a proof of concept, if you will. It has test scenarios. It has bugs. It has the idea of estimates, the idea of release planning. It has iterations. Inside the iteration, that's where things become to be a bit more interesting, because it talks about user stories, it talks about failed acceptance tests, it talks about not just iteration plan, it talks about how we learn and communicate, what do bug fixes look like, what does it look like when we're working in development. And when we're talking about what is missing inside the process, the development is actually part of the methodology here. And this is kind of this is mostly, if we talk about the process in XP, stand-up meeting might look familiar, but there's a bunch of stuff that we haven't talked about that XP explicitly states. Pair programming, refactoring, moving people around to get collective code ownership. CRC cards is more of a design methodology. I'm not going to talk about it too much here. Acceptance tests, test-driven development, it's not mentioned here, but I'm going to talk about it. It's mentioned in the book. 100% unit test pass for new functionality. Those are very explicit, right? You don't find these words. Maybe today you find them, but in the past 20 years, you haven't found these words in agile processes because people don't talk about them, because it looks like that's too much low level. But in truth, these are the gears that make the machine move. And these are the XP practices if you look from the outside in. From the customer perspective, we have whole team, planning games, small releases, customer tests, so acceptance tests. At the code level, we have collective ownership, continuous integration. So this is team level, how people communicate, coding standards. At the pairing level, we have test-driven development, pair programming, simple design, and refactoring. So this is like an inner feedback loop, a middle feedback loop, and an outer feedback loop. Now, let's try to put them into these categories, because those categories really are important for us, especially if I'm going to talk about them, so we can focus. So we have a developer on one side, we have code on the other, and we have customer on the third side. So developer and customer, in terms of the practices from XP, we're talking about developer working with customer. So XP is talking about on-site customer. not necessarily a product owner, but a real customer of the product if possible. That's one of the reasons it was called extreme programming, but also because pairing and TDD feels extreme for a lot of people. System metaphor, it's about the language that we use. When we talk about the part of the system, we always use the same word. So it's about creating a dictionary that we can all talk about together. 40-hour work week, right? This is about sanity. But I'm going to talk mostly about the things in white. Code and customer, it's about small releases. So the customer interacts with our code through small releases and gives us feedback. This is relating to continuous integration and continuous delivery. And in the middle, developer versus code, we have simple design, refactoring, coding standards, collective ownership, pairing, and TDD. And in the connection of all of these, we have the planning game, which we're not going to discuss because planning has been beaten to death. It's like a dead horse by now. Planning is not the issue that we're trying to solve at this point. There are a million ways to plan. Continuous testing and continuous integration brings the entire thing together. This is the thing that actually integrates all these parts. Let's jump into them really quickly. Testing and test-driven development. XP talks about the idea of test-driven development as a first-class citizen. Sorry, takes a while. So if we have a first-class citizen called a TDD, it means that we're explicitly saying that when we're writing, we actually start with a failing test, and then we're writing the code, and then we're making the test pass in the simplest way possible. And after that, we move on to the next test. So testing and test-driven development is at the heart of extreme programming. However, you might have heard about it from multiple different sources because TDD is an engineering practice and you can take it as is and implement it in any methodology because it is not about the process outside. It is about you and your code. It is about between a person and their computer. It is your choice whether you get to do it or not. It's like debugging. Nobody's telling you whether you should debug your code or not when you're building a new feature, right? You get to choose, you do it. That's just how you write code. TDD is also the way we write code because we want to get confidence, because TDD actually gives us more courage to continue faster. It's a very powerful technique, and it feels like it's going to be scary to learn, but I can tell you that it's not complicated to learn it. But it is very, very powerful. The next one is refactoring. By the way, if I asked here people, how many people here actually practice TDD in their day-to-day job, my guess is that not a lot of people are going to raise their hands, right? And especially because most people don't have their webcam, so I'm definitely not going to see a lot of hands. But if I asked you, not only you, but how many of the people that you actually know in your organization actually practice it, the answers are really, really, sad sometimes because there are many reasons why people don't practice TDD. And if I asked you what are the reasons that you don't practice TDD or other people, I'm sure you're going to find a lot of really, really good ones. Some of it is, well, we've never practiced it, or it looks complicated, or you know what, it takes too much time, it's wasting too much time, we just want to get on with it, or I tried to do it and my manager said I shouldn't do it, or I tried to do it, but it's really complicated in our code, there's a lot of legacy code that's really complicated, it's untestable, so many other reasons, right? But at the end of the day, TDD is what allows us to move faster. So if we find a way to do it, that's part of the oil in the machine. The second one is refactoring. Refactoring talks about the idea that we change the code without changing the functionality. And that means that we are allowing ourselves to change the code and change the maintainability and the readability of the code without actually changing the functionality of the code. This is what also enables us to write tests later in an easier way, to understand something when there's a bug that's happening. So refactoring is a key technique. But if I ask people here, how many times do you personally get to practice refactoring on your actual source code? Or how many developers have it, or how many people do you know that practice refactoring as they code a new feature, but they look at something they don't like and they actually refactor it to make it better? It's not very well used. It is more used than TDD, I can tell you that, because some people treat the idea of refactoring as a big bang. So sometimes in a team, you'll have a refactoring week, where you'll have, okay, we have this big chunk of stuff. We're all going to refactor it together. We're going to create this huge branch, and it's going to be this huge risk to the entire organization because we're going to do this refactoring. But what I mean here is continuous refactoring, small chunks, very small stuff, things that take minutes. So even if you have a big refactoring to do, you can do it over months in small increments as you work through something. And again, refactoring is mentioned specifically as part of XP because we want people to be able to have code that is maintainable and readable. Otherwise, it's technical debt and it becomes slower and slower to work on your code. And then it doesn't matter how fast your iterations are. If it takes you 3 weeks to add a feature because you're afraid of adding that feature, so you create a copy of the entire piece of code just so you don't break anything. Of course, then you have to test the whole thing. And of course, you don't have automated tests because you didn't practice TDD and nobody has time to write the test after the code is written. So now we have to do everything manually. Then of course, we're not going to be able to reach a sprint that takes 2 weeks. Every 2 weeks, we're going to sit there and say, well, what did we do wrong this time? Well, we didn't have time to do this and the thing and the man, we really have to do this. Oh, let's do 1 week sprints. Not going to make a difference. We're just going to be unsatisfied faster. So what else? Communication, pair programming, learning, collective code ownership. Pair programming is a key, powerful. If you want a power move to do in your organization today, pair programming is one of the most powerful things that you can do. There are many things that are great about pair programming. The problem is that managers hear pair programming and they become pale, right? They become like pale in the face. They lose all their blood. What happens? Because they hear, what, 2 people on the same machine? Really? How does that save me money? Other than hardware, I guess I need less hardware because it's 2 people on 1 machine. But does it actually save me? Does it actually, everything is going to be slower. And the answer is, of course, it's not going to be slower. If anything, it's actually going to be faster. The problem is that when we are measuring how long something takes, we are trapped in the efficiency world, which means how long it takes to do just a coding task. But we have to remember that we have coding and testing and feedback loops and continuous changes to that code. Pair programming actually enables writing faster code with better understanding. And on top of that, you get knowledge sharing and you get code reviews for free. It's a very, very powerful thing. So if you have an organization where you have, for example, in a team, you have 1 person that knows how to work on the front end and 1 person knows how to work on the back end. One of the best things you can do is to have them pair program together on each other's tasks, because you're removing bottlenecks inside the team. You're teaching people how to contribute in other areas. Not all people are actually going to like this. Some people are not going to like it at all. But to enable that type of work where we have collective code ownership, which is the next item, we have to have knowledge sharing. We have to be able to touch other people's code. Pair programming is a great way to achieve that. It also enables better quality because you get that built-in code review and you're thinking about design and you're talking through a mission together. It's very, very powerful. Not everything has to be in pair programming. It can be very draining, but at least 2 or 3 hours a day can be very, very powerful. Collective code ownership is when if I see a problem in the build, I can kind of at least debug it or understand where the problem is. I can kind of fix a quick bug if I need to. I don't have to be an expert in all pieces of software. I can be an expert, let's say, in front end, but I can muck around with the back end if I truly need to. And that's what collective ownership means. It means if I see something, I don't feel afraid to change it because, first of all, I have tests to protect me and they'll tell me if I broke something. And also because the mentality in the team is that you're expected to touch things that bother you. Always leave a place better than you found it. Continuous integration, I think we all know what that means, right? The idea that on every commit into the master branch, we have integration with everyone else's code. Now, continuous integration is very powerful because it gives feedback. My code compiles with your code, that I didn't break your stuff. But in many organizations, if I asked you if you're actually doing it, you might wrongly say that you do when you don't. And the reason that I say that is that many organizations have builds that run on commits, but the code never reaches those master branches fast enough. So code might live in a separate branch for 1, 2, or sometimes 3, 4 weeks until it actually reaches the master branch, which means that it's not continuous at all. The code that I'm compiling now is a code that started a month ago. That's not continuous. What is continuous integration? It means trunk-based development. It means that I'm working mostly on the master branch, and or if I do work on feature branches, I work on very short-lived feature branches, a day or less. And if I need to commit and my feature is not done, I use feature toggles to hide the feature so that I don't break everyone else's code. That is true continuous integration. So even if you're working with a healthcare company and you cannot release because you have the FDA and it takes 3 years, you can still do continuous integration and make sure that your code doesn't break everyone's code, even at least locally on a build, not just nightly, but technically on every commit, you should be able to do that. That's difficult because it requires, again, learning these engineering practices relating to key stuff that we all need to know and learn about, whether it's refactoring or naming conventions and coding standards, feature toggles. Most developers that I know still don't know what feature toggles are, or they've heard feature toggles, but they don't realize that there are actually 4 different types of feature toggles. We have customer toggles, we have A/B testing toggles, we have operational toggles, and we have dev toggles, which is what we're discussing here. So I would recommend, like all these things, they take time to learn. I'll talk about that problem in a second. So just talking about these things requires a lot of learning and practicing engineering skills. And of course, if I ask you, well, why aren't you doing all those things? I'm sure you're all going to have a very, very common answer. Let's see if I can guess it. Time. You don't have time to learn all that stuff. Let's see. Well, of course you don't have time. Nobody's got time for that stuff. We're too busy shipping software. We're too busy fixing our mistakes from 2 months ago. We're too busy, putting out the fires that we don't have time to prevent. We are too busy to avoid this. So of course we're not going to do all that stuff. And I call this the survival addiction, survival mode. I'll talk about what survival mode is. But a lot of organizations, a lot of people in organizations are used to working in what I'll call survival mode. Survival mode is when you don't have time to do anything but survive. Just keep your head above water. And some people are really good at surviving. Some people are really good at getting up at 2 in the morning and fixing the build and becoming the hero. Some people are really good at going frantically around and just getting that build out just after that one. Oh, we got it. Perfect. And then they're heroes. Some people are really good at managing that type of stress. It's not scalable and it's not sustainable. And of course, it allows us to avoid learning completely. And that's where I'm going to talk about the idea of survival mode, learning mode, and self-organizing. All teams, organizations, as far as I can see, exist in one of these 3 states overall, either survival mode, learning mode, self-organizing mode. Survival mode is the most common. That's the mode where you don't have time to learn. It's the mode where you actually are just literally trying to survive. I don't expect anyone to be able to learn test-driven development if they're fixing a fire where the customer is going to fire our company if we don't ship this stuff. Of course not. That's not realistic. And a consultant or any coach that tells you, oh, no, we should all just stop, hold on for a second. Let's just stop and just think about what we're doing and let's do it the right way. It's not realistic because the company will not survive. The team will not survive. That's a problem. So I call this the elastic leadership model, but the basic idea is this. If you want to be able to get to all those engineering practices and to actually prevent those things, we have to get out of survival mode. So first of all, we have to realize we're in survival mode. And after that, we can start planning how the hell we get out of it. So the basic idea of getting out of survival mode is that we plan a time in the near future, which is maybe a month from now, where we re-estimate our current tasks. Because right now we are in firefighting mode. But in a month, we're going to be done with the fires for this month. And what we're going to do is we're going to plan with our management what's going to happen in a month. We're going to reset our estimates. because survival mode comes from two things: unplanned work and over commitment. Sometimes we are overcommitted and we promise to do too many things, and so we have zero time to learn. We need slack time. We need free time so we can learn and practice slowly. To do that, we actually have to take a leadership position and actually demand that. Not demand, but find a way to achieve that with our leadership, or at least to explain that the current situation is spiraling out of control, because it will never get better unless we get out of survival mode. It will only get worse. So just as a basic idea, survival mode, how do we know if we're in it? We have no time to learn and slowly practice. We are just reacting. We are overcommitted. Learning mode is where you want to be so that you can arrive at that state where you can actually be in self-organizing. Learning mode is where you actually learn all that stuff. That's where the coaching happens. That's where all the coaches are doing their best work, when the teams have time to learn and make mistakes. But for that, you actually need time. So just realizing that we need that time and that we can plan how to re-estimate and remove commitments so we have that time, that takes a leadership decision. But at least now we know what to ask for. Now we know how to explain it. And again, if you Google the Elastic Leadership Model, I also have links at the end of this. I'm happy to discuss more, and there's a bunch of YouTube talks that I did about this. So just to summarize, and then we can do a quick Q&A. The root causes where so XP in itself, or the engineering practices, they're kind of a no-brainer. I mean, I don't think that there is any disagreement that we should probably do that stuff. I think we all agree, hey, that's good, let's do it. The problem is that we're not doing it. The problem is that we're not sure why it's not happening. So I want to talk about what we can do as the next steps. The first thing we need to realize is, what are the root causes? We understand what is the state that our team and organization is in, and we have to act accordingly and actually change our estimates or commitments so that we have time to learn, because otherwise we will never learn those practices, and we'll never be able to practice them, and we'll never be able to actually achieve those things and actually give the organization what they were asking for. The organization doesn't know that it's missing because we never said so. Or maybe we said so, but we couldn't explain ourselves in a way that they understood. To do that, we need leadership skills. We need to be able to explain that. We need to communicate, and we need courage, because it's scary to go ahead and ask your manager to say, well, we are overcommitted, right? We're overcommitted, and if we go down this road, it's not going to end well. I'm broken. I would much rather be the hero that says, I know it's crazy. I know it's very difficult. We're going to work until 2 a.m. and we're going to get it going. You can trust me. That is not sustainable. To me, that is not a leadership position. This is a temporary position. It can be temporary, but it has to be temporary. It cannot be the strategy. And lastly, we have to realize we have a culture of efficiency, which means that we are usually looking at a small role to optimize how busy people are. If people are constantly busy, they will never be able to learn those new practices, which means we need to enable people to be less busy. We need to see people that are learning, yes, on the job learning, and available so they can actually practice those things and slowly do that. One way to get your management on board with that is to see where the bottlenecks are and to do value stream mapping. Just a quick recap of value stream mapping. Value stream mapping is the idea of mapping what does it take from an idea in your organization all the way to cash, concept to cash, and mapping how long it takes for each stage in that at the organizational level, like all of the handoffs between all that stuff. And you need to get a bunch of people in the room. Will take 2 or 3 hours. You get a person from each of the stakeholders that help deliver something, from product owners to, let's say, security to compliance, and they help basically map out what does it take to request, approve, and sign off, analysis, deploy. It doesn't really matter. Everyone has a different process, but we map out how long does something take. Wow, it takes us 8 months to deliver a feature on average. Okay, where are the biggest bottlenecks? Why does it take so long? Because what happens is that people look at the coding and they're like, oh, I will optimize the code. But even if we take the code and we optimize that by 50%, at the systematic level, I've done very little in terms of change of how long it takes me to deliver. And that is what management truly cares about, how competitive we are compared to other organizations. So if we can prove to them that by optimizing differently, we are able to deliver faster, We have a faster lead time. A value stream map is an amazing exercise that everyone should learn to do. It's a great communication tool. It's a bit scary to start with, but it's highly recommended. And I highly recommend that you do things that scare you anyway. That's the best way to learn. So if it scares you to try and do it, I highly recommend that you do it. Because for every organization that doesn't want to do it, you can also find an organization that will. You can for any engineering manager that tells you that you shouldn't do refactoring in TDD and you've tried, you'll find someone that does. Of course, there's always going to be systematic issues. So as long as everyone is on board, what matters is that you can do small improvements. You can slowly remove commitments, slowly have more time. But as long as you have a plan, you should be good to go. At least be aware where you are, what are you trying to achieve. And with that, you can go to Elastic Leadership to learn about that, Pipeline Driven to learn about the pipeline stuff, my website, and 5 Whys, which is the blog that talks about all the leadership stuff. And that's it, basically.